Hello and welcome to Mrs. Law's class. In this video, we're going to take a look at the hyperbola. Specifically, we're going to take a look at the hyperbola's features and also how to graph it. Now, a hyperbola is a graph and it consists of two curves because it's created from slicing two cones, which are end to end. And we're going to slice the cones parallel to the axis of symmetry. So the axis of symmetry is right down the center. And when we cut the cone parallel to this axis of symmetry, we're going to get two parts that are cut off. And these two parts are what create the hyperbola. So the hyperbola can open left and right, or it can open up and down. Now that depends on the equation. So we're going to take a look at this a little bit more closely. So taking a look at the one on the left, we can see that the center is going to be 0, 0. Now, the center isn't really part of the graph, but it's going to help us to draw the graph. Now, in this left hyperbola, we have an equation, and it actually looks very similar to the ellipse. It's going to be x squared over a squared minus y squared over b squared equals 1. So the only difference between this and the ellipse is that instead of a plus between the x squared and the y squared, it's actually going to be a minus. Now, if the equation opens up and down, the center is, in this graph that we have, is 0, 0. And the equation will be x squared over a squared minus y squared over b squared, and it equals -1. So when it opens up and down, it's going to equal -1, but when it opens left and right, it will be +1. Now we can also multiply this equation through both sides by -1, and then we also get a reverse x squared and y squared. So we get y squared over b squared minus x squared over a squared, and this equals +1. Now if we do have a change in the center so that it's not centered at 0, 0, we can also change the equation to x minus h all squared over a squared minus y minus k all squared divided by b squared equals 1. And same thing for this part too, when it opens up and down. So x minus h all squared divided by a squared minus y minus k all squared divided by b squared equals -1. Now remember that xy represents a point on the hyperbola, just like xy represented a point on the ellipse and also a point on the circle. Now, what do these values a and b represent? So the a is the distance from the center to the right and left edge of an imaginary rectangle. So in my diagram on the left, this would be from the center, which is here, to my left side and my right side. These points are actually called vertices, or a vertex for one. And the same thing on the one on the right, we would have 2 points, which represent the distance from the center to A. So I'm actually going to label this A, and this is distance A and A. B, because it's underneath the y value, that represents the distance from the center, but this time to the top and bottom edge of an imaginary rectangle. So on the left diagram, let's say that this is up here and over here. So this is B and B. On my right diagram, this would be from the top and bottom, and this would be B and B. And again, these 2 points represent our vertices. So what's the point of these a and b values? Well, the two curves of the hyperbola, they're actually bounded by 2 asymptotes. And these asymptotes cut through the center and the corners of the imaginary rectangle. So let's say that I draw in an imaginary rectangle, and I'm going to use a dotted line here. And we'll do that for the other one on the right as well. Okay, so the asymptote cuts through the center and also through the corners of that imaginary rectangle. And this asymptote, or these asymptotes, act as a guide to help you draw your hyperbola. Okay, so these are our asymptotes. And they're useful. We don't draw them in as solid lines, but we draw them in as dotted lines because asymptotes are guides. They're not actually the graph, but just helpful lines. Now, some terms that we need to know in addition to the asymptotes and the vertex. Actually, the first one is a vertex. So these are the two closest points on each curve of the hyperbola. So these are the vertices, or the vertex for one. So the vertex, or the vertices, are always connected to the hyperbola. So they're always on the hyperbola. So here and over here. Now, the axis that connects these two vertices, so the distance from here to here, or from here to here, this is called the transverse axis. So this is called the transverse axis. So let's fill the blank in. So transverse axis. So they are the points, or sorry, the length that connects the two vertices. Now the other direction, simply it is just the other direction, and it's perpendicular to the transverse axis. That one is called the conjugate axis. So that would be, in this case, the other direction. So this, on the left picture, that would be the vertical, or sorry, conjugate axis. And in this case, it's on the y-axis, but remember, if we move it and it's no longer in the center, it's still going to be the conjugate axis. On the right diagram, the conjugate axis is a horizontal line. So conjugate axis. Okay, so just to emphasize this again, the transverse axis is the axis that connects the two vertices, and the conjugate axis is the one that is perpendicular to the transverse axis. Now, note that the transverse axis is not always the longer axis. Sometimes it can be long, but sometimes it could be the shorter one. Now, one more thing when graphing, make sure that you always change it to standard form first, and then keep in mind the direction of the opening, whether it equals +1 or -1. All right, now that we've looked at all the different features, let's graph some hyperbolas. So let's enlarge this a little bit so it's easier to see. All right, so we're going to graph these two hyperbolas, but we're also going to state the center, the length of the transverse and conjugate axis, and the slopes of the asymptotes. Now, we can see that for both of these equations, they don't equal 1, so they are not in standard form. So the first thing that we need to do is actually to change to standard form, and we'll do that by dividing by the constant. In the first one, it's 400. So we're going to divide every term by 400. And then we get x squared over 100 minus y squared over 16, and that equals 1. So now it's in standard form, and we can see that the center is 0, 0. Now, because it equals 1, and we lead off with x squared, we know that this hyperbola opens left and right, which means that the transverse axis is going to be this horizontal distance here. So to find that, we're going to square root the 100, and then we're going to times it by 2, because remember, the 10, when we square root 100, that's only the distance from 0 to either the left or the right side. So this gives us 20. The conjugate axis is the perpendicular one, so we're going to square root 16. We times that by 2, and we get 8. Now, before we look at the asymptotes, let's draw the picture so that you have a better visual here. So the center is at 0, 0. So we're going to plot that. We're going to count 10, which is the square root of 100, in the x direction. So that goes to here and here. And then we're going to count vertically up and down by the square root of 16, which is 4. So we're going to plot that here and here. So we're going to create that rectangle. So we're going to plot the corners. And remember, the purpose of that is so that we can draw in the asymptotes. So let's draw in the asymptotes. So grab a ruler. In one direction, and then we're going to go in the other direction as well. So make sure that you draw a ruler. It's hard to do that on the computer here. And then what we're going to do is then, starting at our, because we know it opens left and right, starting at our vertex of 10, 0, we're going to draw our hyperbola. So these can be rough sketches. They don't have to be perfect, but do make them approaching the asymptotes, and then don't make them too pointy or the vertexes. And there you have your hyperbola. Now the slope of the asymptote we can see is from this value here, the vertical, our rise, and our run, which is over here. So we can see that the rise is our B value, and our run is our A value. So therefore, the slope of the asymptote is going to be 4 over 10. And because we also have a negative asymptote, we have plus or minus 4 over 10, which equals plus or minus 2 over 5. All right, let's do the second one, where it is not centered at 0, 0. We're going to divide everything through by 36. So we get x minus 2 all squared over 9 minus y plus 1 all squared divided by 4. And notice that it equals -1. So we know that the hyperbola opens up and down. So the center is at 2, -1, because it's minus 2, and it's y plus 1. So our transverse axis this time is the vertical distance. So it's going to be the square root of 4 times 2, and that's 4. And then the conjugate, which is perpendicular to the transverse, is the square root of 9 times 2, so that equals 6. Now, we've done the asymptote from before, so we know that it's going to be, I'll write that over here too actually, it's B over A. It's always going to be over A because that's our y value, our rise, divided by our run, which is our horizontal, so that's our A value. So this will be plus or minus 2 divided by 3, the square root of 4 divided by the square root of 9. So we're going to plot our points. So we have 2, -1 as our center. In the horizontal direction, we're going to plot a point 3 away from the center because it's the square root of 9. So here and here. Our vertical is the square root of, so our B value is the square root of 4. So we're going to count 2 up and 2 down, and then create the rest of the rectangle. All right, so grabbing a different color so you can see this a little bit better, we're going to draw in our asymptotes. And then don't forget that the graph opens up and down. So we're going to start at our top vertex and draw our hyperbola opening up. And then from the bottom, our hyperbola opening down. And there we have how to draw a hyperbola.